Thank you for joining this webinar. We like to collect open-ended text data as it allows people to tell us what they really think. But once you have the data, life can become really difficult. How do you sniff out the truffles hiding in all that text? Today, I'm going to show you how to do it quickly. As always, I'll be presenting from within Displayr as it's designed for sharing data stories, but everything I'll show you can also be done in Q. I'll start with a quick overview of what's new in the software. Then I'll review the goal of text analysis and the concept of machine understandable text. Then we'll look at how to quickly categorize text data using semi-automatic and automatic categorization. Lastly, we'll focus on the special case of how to code lists, such as brand lists from spontaneous awareness questions. Since the last time I've done a webinar on text analysis, we've made huge improvements to semi-automatic categorization, and over the next week, it's actually going to improve quite a lot again. The thing that we've particularly worked on is making things work well for multiple response data. Over the next couple of weeks, there'll be a new version come out with easier translation of languages built into it, so you can do your coding in any language and view it in any language. Now this will come out automatically in Displayr, but if you're a Q user, it'll take a little while to roll out. But if you're kind of desperate to get the automatic translation, then just write into the support team and tell them you want to be upgraded as soon as possible. And we're continually trying to make the text analysis a little bit faster, but we've got quite a bit more work to do on that. Many people have a misunderstanding about the goal of text analysis, so I'm going to start by focusing on that. And I'm going to be illustrating using one of my very favorite case studies. Some years ago, we asked people how they felt about Tom Cruise. Now, to appreciate this data, it's just after he jumped over the couch on Oprah Winfrey, for those of you who are a bit older in the audience, and just broken up with Nicole Kidman, and it's well before he became cool again with Maverick. Some people are really quite unkind. The most unkind one's data has actually been deleted. So this is what the first 13 of about 300 people in this data set said about Tom. The simplest reporting option is just to give this raw data to the end user or the client. Most people don't want to do this because it's quite hard to find the information. They want to add a little more value. Now, the mistake I think that gets made quite often is where people try and come up with a cool visualization as a way of summarizing the text. I think this is a mistake. I'm going to show you various ways to do it because, my view of a mistake might be your idea of genius. You can, of course, do word clouds in our software. Word clouds rarely give a lot of insight. This one tells us that some people like Tom, others think there's nothing wrong with Tom, some think he's crazy, some think he's a Scientologist. A word cloud is pretty simple, but a network is kind of cool. Here, the thickness of the lines show the relationships. Now, in the 20 odd years since I first saw one of these, I've actually never seen one of these that revealed any insight, but I've seen people misread them. So let's focus on how to read it correctly. This tells us that Tom and Cruise are commonly mentioned together. That is, like, people might type Tom Cruise. Some people that say Tom say like. So Tom Cruise and like are commonly going together. Good and actor are kind of linked together in the data. So that's what it says. Again, I don't think there's a heap of insight in that. Word maps are like word clouds, except the proximity of the bubbles tells us which things go close together. When you're told we used an algorithm to find the bigrams and the trigrams and the n-grams, it sounds kind of cool. But all it means is you find the most common words and phrases. So the big insight that comes out of this type of analysis here is that Tom and Cruise go together. And we can see down here that people that have said like also sometimes said don't at the same time. Don't like. It's a bigram, 2 words. Again, I don't think there's a lot of value in this kind of stuff, but you can do it. So I've gone through the techniques that I don't think are that useful. How should we do text analysis? I think there's a way to think about it. Step 1, which I'm going to return to shortly, is collect machine understandable text. Step 2, and this is what I think of as text analysis, is to convert the text into numerical categorical variables. We often call that coding in market research. And step 3 is just to do standard quant analysis on that data, the way you would ordinarily do it. So looking at the Tom Cruise data, we've got the text on the left. I've coded or categorized it. You can see here I've said doesn't look genuine. I've put in crazy weird. Thinks it's too cool. I've put in arrogant. Don't like the acts better than anybody else. Put that in arrogant. And then the analysis is just a crosstab shown here as a bar chart, showing us that, for example, we can see that disliking for Scientology is a more common concern amongst women than men, done a good old-fashioned stat test. So completely standard bread and butter analysis. So the hard bit is the middle bit, step 2. How do we convert the text analysis into numbers? I'm going to first go through some quite sophisticated techniques, which I don't think are usually that useful, but I just want to share them. And after that, we'll go and we'll look at the techniques which I find more powerful. Sentiment analysis counts up the positive and negative words, where the difference between the two is referred to as somebody's sentiment. There are more sophisticated algorithms that people use from time to time. This can be useful in some fields. It's rarely very useful for market research data because in market research, we get to choose the questions we ask. And so the best way to measure sentiment is to ask, how much do you like Tom Cruise? Would be the way you get it. A more exotic technique is called entity extraction. The way this works is it hunts through data looking for entities or things that are kind of well identifiable. And so, for example, we can see here, it's gone through and it's looked through the text for all job titles, actor and actor. It can be useful. Autoencoders, including our own technique called principal components analysis of text data, don't create categories. Instead, they assign numeric values on multiple dimensions to each text response. This approach to turning text into numbers is most useful as an input to more advanced techniques like as regression or latent class analysis, if say you want to do a big segmentation and include text variables. So there's some of the more advanced techniques. I'm going to return to the more basic and actually not more basic. I'm going to return to what I regard as the most powerful techniques for day-to-day research shortly, but first a little detour. If you know you're going to use text analysis, you should take the time to collect machine understandable text, if you can. Consider how you talk to a chatbot or Siri. Do you talk like this? You probably don't. You understand it will confuse the computer. You'll be more likely to communicate like this if you know you're talking to a chatbot. To use the linguistics jargon, we talk in pidgin. You'll get better results from text analysis when you try and collect data in pidgin. In the days before we used software to automatically categorize text data, it was really clever to ask genuinely open-ended questions. For example, question 2 here. But a computer will do a much better job with a more focused question, like this question 2. And it'll do even better again with a version like the question 2 shown on the far right. Now, it's a trade-off. I'm not telling you that you need to use the question 2 on the right. I'm just saying that if you do, you'll get better analyses out of automating things, or automated analyses will work better. You've just got to make a trade-off in terms of which you want to do in a real study. So once we've got machine understandable text, how do we go about turning it into numbers or categories? What are the best techniques? We just looked at some of the exotic approaches. We're going to dig into the most useful approaches. The classic way to categorize text is to have a person or a team read through the data and allocate people into categories. In market research, we call this coding, but text categorization is a less confusing name for non-market researchers because a lot of people think of coding as writing software these days. Now, when you get people to categorize data, they're really good at it. Our brains are optimized for this type of problem, and so the accuracy is really high. But we're super slow at doing it, and this means it's really expensive. An alternative is to use software to automatically form the categorization. I'll show you how to do that in Displayr and Q shortly. When you do this, you solve the money and time problems. It's fast and it's cheap, but there's a big cost, which is the accuracy goes down a lot. You can hire a data scientist to do some text modeling. When you do this, you lose your fast and your cheap again. And you tend to do quite poorly in terms of accuracy. A technique that we call semi-automatic categorization is designed to use algorithms to help people do the categorization or the coding. I'm going to show you how it works shortly. The thing about this approach is it's able to be highly accurate and it delivers savings in terms of time and money. It's not as fast or cheap as fully untrained automatic categorization, but it's a lot faster than manually coding data, particularly for larger data sets. Now, the idea of semi-automatic categorization is really similar to the idea of robot-assisted surgery. For those of you that have had surgery recently, you've probably had a computer driving a robot where the surgeon was doing the overall control of the process. So it's still a person driving it, but the robot assists and does the routine or the little fine things that the human's not quite good enough at doing. Same idea with semi-automatic categorization. Now we're going to explore how to do semi-automatic categorization by looking at our Tom Cruise data again. It's kind of hidden a little bit in the menu, so these instructions for doing it in Displayr and Q. Let's go and do it. So I'm going to bring in a data set. Now, to do it, I've got to click on the text variable that I want to analyze. I click this little plus button and I go down to text categorization. We're going to do it semi-automatic. Now, we can choose to force everybody into one and only one category, but that's rarely that relevant or appropriate. We're going to choose multiple overlapping categories. It's going to create multiple response data to use the market research jargon. Now, this is going to take a little while. In the background, Displayr is doing a lot. It's finding all the common words, the bigrams, the trigrams, and the n-grams. It's calculating sentiment. It's doing that auto-encoding that I talked about before. It's actually converting every response that somebody has said, each bit of text, into a long sequence of 1,024 numbers that summarize that text. It's doing another algorithm called a random forest, and then good old-fashioned cluster analysis in the background, which most people are pretty familiar with. A lot of heavy lifting is going. And what it's initially going to do is just create an untrained automatic categorization. And ta-da, there it is. So it's put everybody into 18 different categories. We're looking at the text data on the left of each respondent. We can see what categories they've been put into, and the numbers here, the colors line up to the numbers and colors on the right-hand side. Now, you can see that in this case here, it's categorized 89% of the data. So we've got a few people that we need to categorize manually. The best place to start though, when you're using the semi-automatic categorization, is to look at the automatic categories and figure out how you're going to play around with them. That is, particularly which ones are bad categories, because computers find patterns and the patterns are sometimes not interesting. Let's look at the first one, Scientology. By quickly scanning it, we can see that these 23 people have all mentioned Scientology. Scientologists, all right, that's clearly a clump of people. Just gonna, Tom Cruise. Okay, we've got a whole chunk of people who mentioned Tom Cruise. Questions about Tom Cruise. I'm just going to delete that category. It's not very interesting. Religious, okay. Religion, all right. So these three categories here, Scientologist, religious, and religion, I think should be merged into the Scientology category. So I select them, I right click, delete and reclassify as Scientology. The next category we've got is crazy. And people have said that. This person down here has said brainwashed cult, so I'm going to add him to the Scientology category as well. And you can see now the numbers update. So he's now in both categories 1 and categories 2. So we go through each of the categories, checking that it's good enough. We merge categories. We can delete categories that we don't like. The next thing we want to do is look for any categories that have maybe been missed. And so I'm going to change to show responses for the uncategorized people. So this person said ego. There's a category here called arrogant, which that's kind of ego. So I'm going to move him into that. Not sure. So if you think about not sure, it's kind of like saying nothing. I've got 2 nothing categories here. Let's go have a quick look at them. First nothing. Okay, there's nothing I don't like about him. Second nothing. This is 2 nothing. So the computer's found a pattern which it thinks these nothing categories are different in some way that's not interesting to us. So again, I'm going to delete and reclassify as nothing. And I'm going to return back to looking at all of my uncategorized data. Not sure. If you don't know, I'm going to put you in nothing. The left, Nicole Kidman. I think maybe I did another category. Not applicable, missing data, Christian Scientist, I'm going to call that Scientology. Church, Scientology. Now, I can go through and manually do these, but you get the basic idea. As with all coding, you can decide how good you want to be. I'm just going to chuck them all in other, just a bit lazy. Now, the next thing we can do is we can check the quality of each of these categories and the boundaries between the categories by using a technique called fuzzy matching or similarity to. Now I'm going to do the similarity to, and the basic approach of this is I'm going to firstly look to see for all of the data, all responses, which responses are similar to Scientology categories. So here in the background, it's doing some machine learning and trying to predict which categories are in Scientology. The orange bar shows us how confident it is in the prediction, and this number 1 is actually telling us we've already categorized them as Scientologists. So I scroll down here, and I want to go to where the kind of borderline between it, and we see, okay, this person here, the algorithm's not sure it belongs in the Scientology, but it's reasonably close. And we can see they have said religion, so I'm going to put them to Scientology. He's a control freak and a crazy religion. I'm going to add that to the Scientology. Crazy, well, that's not it. This person's mentioning religion. And we can multi-select, obviously, and save a bit of time. And so we can go through that same approach for each individual segment and just tighten those definitions up. Again, how much time we spend will determine how quality our work is. We get to decide if we're cheap and dirty or we're going for gold. Another thing you can do is if there are categories that you suspect might be in the data but haven't been automatically discovered, or you see them in your qual or something like that, you can look for fuzzy match. I'm going to type I like him. I'll just sort the data, point to everybody who said I like him. And then if we see groups, so I love him, that's similar, it's in this cool category. And then we can just, again, create a new category or merge things about. So that's the basic process. I won't bore you by finishing it. I'll just click Save Categories. It adds the data to the data file. I drag it across, and we just use it like any other data. And so we can see here, for example, let's increase the font size on that. You can see here that crazy is more likely to be said in the Midwest. So that was semi-automatic categorization. Here's some tips, just going through what I went through and showed you in the example. The next approach is trained automatic categorization. These are the instructions. Now, trained automatic categorization is where you first form categories using traditional coding or maybe semi-automatic categorization. So maybe you categorize your first or random selection of 200 people, and then you use machine learning models to automatically categorize all of the remaining data. Now, the advantage this approach has is it's faster and cheaper than the semi-automatic categorization, but it's more accurate than the untrained automatic categorization that I showed you before. It tends to be less accurate than the semi-automatic categorization. We're going to do a case study. Here we've got data on what you like about your current phone company. So in this data set, I have got some data where I manually went and I categorized the first 2 weeks of data in a tracking study, looking at what people liked about the US phone companies, cell phones in particular, mobile phones. And you can see here it's just showing my data from my first 2 weeks. I want to use automatic categorization to fill in the data for all of the other weeks. How do I do it? Well, it's kind of hidden in the menu, I will say, but fortunately we can just type automatic categorization. Oops. And display a little yellow brick road, as the sport term like to call it, will show us the way in. And I'm going to choose the option called unstructured text. And I then drag across the data on what people said they liked, drag across the categorization that I did before. That's the first 2 weeks of data, and it's now going to build that model. Don't worry, we don't have to wait for it to happen. It takes a couple of minutes. This is the output that we're going to get. Now, there's a whole lot of detail here we're going to have to dig into. It's quite important that we understand exactly what's going on here. In this first row of this table, it's telling us that I had provided data which showed 155 people and that had been categorized as price. And I can see over here all of the people. The model has gone in and it's identified a total of 669 people that it thinks are price. So it's applied my categorization to all of the newer data from weeks 3 through 10. The model thinks it's 100% accurate, which means that every one of these 155 people that I'd manually classified as price, the algorithm has been able to also categorize as price. And you might think, great, this model's perfect, but this is always an exaggerated claim. Models, particularly text analysis models, are usually very good at explaining historical categorization. The thing we need to check, though, is that they accurately explain categorization in the future. Unfortunately, there's a cool little analysis at the bottom written in a very small font, which I need to discuss with the data science team one day. I don't quite know why it's in such a small font. What it's done here is, what the algorithm has done is, and I'll just focus on the bottom row, there are a total of 482 people that I manually categorized. That is the data from the first 2 weeks. What the algorithm has done is it's just taken a random selection of 200 of them, and I said the algorithm, I mean the software. It's randomly taken a sample of 200 of those people, and it's built a model, and then it's predicted the classification for the remaining 282 people. And it wants to check its accuracy by seeing how well it predicts for these 282 people where we do know their true classification. And it says here the average prediction, or the total prediction I should say, is 95.4%, which sounds really good, but the better metric that most people like to use when looking at categorization, I say most people, I say many academics would be more accurate description, is something called kappa. And we'd usually say a score of 0.8 was very good. So this categorization model is not very good. It's not terrible, it's usable, but we're going to dig into how we can use it and check it a little more carefully. So the way we do this is I click on the output and I go down here and I choose Save Variables Categories. In Q, I would instead go into the Create menu, Text Analysis, Save Variables. And so when I click that Categories button, what it's doing now is it's constructing new variables, which are just added down here for me. And so let's drag them onto the page. Drag across our week data. And so you can now see I've got data from all weeks. So we've successfully categorized all our data, which is great. So that's what we're trying to do. We can start to see the little pattern, which is for some reason, everything wasn't that popular in week 3. But there's a few signs here that this categorization is not perfect. I'm not saying it's not usable. This is vastly better than giving somebody word clouds over time. But there's a few little warning signs here that it's not a perfect categorization. And remember, we also saw the kappa was below 0.8 before. The first sign is, can you see how the significance test is showing us we've got higher scores of most things for weeks 1 and 2, which is when we'd manually coded the data. And what's going on here is that when we coded the data, we have a lot of really small categories. And the problem with small categories is it's hard for machine learning models to predict them very accurately because there's just not enough data. And so it's tended to underpredict membership of a lot of these smaller categories. And that's what's showing up in the significance test. The next thing we can see is that we've got, if we look at the net, we've got only about, well, at least 80% of people have been categorized, but the flip side of that is that less than 20%, but 10 to 20% of people in each of the other weeks, the models couldn't put into a category. So what do we do? Well, the way we should fix this is, well, we don't have to fix it. We could be happy with this. It's still going to catch any gross trends in the data. But what we might want to consider doing is categorizing some more text data to build up a bigger sample to hope that that makes the model more accurate. Or we can, rather than use this fully automatic approach, we can just go back to semi-automatic categorization. That is, go into the categorization, just manually work out using those similarity type functionality in the semi-automatic categorization, which people should go in which segment. It's a trade-off. You decide how much time you want to put into it. These are the little tips I just went through. Now, in market research, we've often got a different type of data where we've said to people things like, which brands can you think of? And these tend to require specialist techniques to analyze well. You can do them using the automatic categorization type technique I've just shown before, but better off using special techniques. This case study here, we asked people which cell phones they used. Let's go, we're going to do it. All right, so I'm going to have a little look at this data first. So these are the responses that people have given us. We've got commas separating them. How do we do it? Well, advanced analysis into text analysis. Whoa, 2 mini menus. And we're going to choose this special thing called list of items. This is specially designed for brand lists and things like that. I drag across spontaneous awareness. And it's going to automatically find all of the categories. It's a lot faster than the other algorithm we looked at before. All right, so it's found that there are 1,325 mentions of Verizon. And now the cool bit is, and I might zoom in a little to make this a bit clearer, it's found that there are 18 variants. So let's hover over Verizon. It shows us that Verizon, all the different spellings and capitalizations and all the different weirdnesses that people have mentioned Verizon. So it's a very clever algorithm. I think it's very clever, but it's not perfect because brand names are often remarkably similar. So you've got to be a bit careful about automatically grouping. You don't want to, for example, inadvertently group Coke and Diet Coke together. And so we can see here that AT&T and AT, the algorithm wasn't sure that they were the same thing. You know, apparently there's a whole lot of people out there who can't find the ampersand on the keyboard. So we're going to tweak it a little bit. We're going to required categories. And we're going to say, okay, anybody that said AT&T or ATT, I'm going to merge them together. Do that. Okay. Similarly, and this is another one. Anybody that said T-Mobile and T-Mobile, I'm going to merge them together. And what we'll see here is this at is going to disappear, and this T-Mobile group is currently at 591, should go up. And indeed, that's exactly what we've seen. See, there's lots of other options for tweaking this automatic categorization. And once we've done it, oops, I've gone too fast. Once we've done it, we click on the output and we go down, and we've got this option here to save the variables into the data file. And again, in Q, we need to go into create text analysis, save variables. I'm just going to do the first category, which will give us our top of mind awareness numbers. See, this variable just arrived here in the file. And now we analyze it like any other data. I drag it onto the page and I do a cross tab. And we can see that for whatever reason, Verizon was big in week 4, T-Mobile was really bad in week 6, and hopefully we can find that we can link that to their advertising expenditure or something. Oops. So these are the topics that we just went through. This is the summary of the various techniques, or the main techniques for categorizing text data. We will send you a recording of this webinar, but now it's question time. What would you like to know? And Sumia says, thank you, we're eager to get translation in Q. Now, both Q and Displayr already do have translation in them. So if you go through and just search through the menus for translating text, you will actually find there is a translating text option. It's just, you've got to do it in 2 steps. You first translate it to English and then you run it, which is not perfect, but the new version that will come out in the next week or so will allow you to choose what language you view your results in and what language the data is in to begin with. Kaz has said, can you code a response with multiple categories in Displayr? E.g. if someone says, I don't like Scientology and he's a bad actor, would I be able to code this as Scientology and bad actor? Yes, indeed. And this question was asked before I showed that. So we saw we could do that. Dan says, will these slides be shared after the webinar? Of course we shall. Yeah, we'll send you a link to the recording and the slides. Hannah says, if you get an error message after this, maybe because the text is too long on some open ends, is there a simple way to make them readable to the program? It's very hard to answer that question, Hannah, but what I can say is if you contact the support team, they will be able to solve the problem with you or for you. There's definitely going to be a solution to the problem, but it's just hard to know without seeing the example. Kim says, can Displayr deal with dual codes? We use one code for the general category and a second for the more specific classification within the larger category. Yeah, this is straightforward to deal with. Let's go and we'll look at the semi-automatic that we were doing before. I'm going to click on it, go over here and I'll go edit categorization, which will bring me back into it. And so maybe I'm going to drag weird. I'm going to just drag weird on top of crazy to show how this is going to work. And I'll call this personality. And so you could have brands or sub-brands. I think you could add subcategories and build it up that way. So you can have lots of nested categorizations and things like that. Ron says, If comments are long, say small paragraphs, will semi-automatic categorization work? Okay, yeah, good question, Ron. Depends what you mean by okay. So when you have long responses, it's not really machine understandable. There are so many patterns in that data, the chance the machine will automatically come up with good categories like the ones on the right is quite small. But what you will find is that the fuzzy match and the sorting, the fuzzy match, which is when we typed a label, typed something and searched for it, and then doing similarity, will tend to work reasonably well. So I would try that. Aaron says, does the classification system handle imperfect delimiters? Now, I'm imagining you mean by this situations where, and I'll show the kind of concrete example here. Oops. So here I've got super neat data with commas, but if you just, for example, gave somebody a text box, and some people might put colons in some spaces, some returns, and some do nothing, it's a little bit more tricky. Yeah, the algorithms are designed to deal with all of those problems, but the messier the data, the less well they will do. It's that machine understandable text point I was making before. Larry, g'day Larry, says, what's the best way to output to Word or Excel the categorizations and the text items within the categorization? Well, in terms of going to Excel, what I would do is I would just, having done my categorizations, I would just go publish, export data, and then send to CSV, which will get me the raw data. Now, if you're instead, and you might be talking about something a little bit different, and there's a couple of other options we can do. Whoops, I'll go back here. So what we could do is we could drag across the text data and then drag the categorization and the columns. And what it's then doing is showing each text response that applies in each of the categories. And then I could just export that page to Excel. That'd be the most straightforward approach. There's no direct word export, but you could, if you really wanted to, go copy, copy data, and then paste it into Word. Mike says, if I already have the code list, could I insert it as the template and train the text analysis model? Yes, you can. The way you would do that is you would take the text data, go in, text categorization, semi-automatic, and I'm assuming you're talking about the semi-automatic. If not, tell me. I'm going to click cancel. Now I could click import, so I could actually export one from one project and reuse it, or I could just go import, export code names and type in all my categories and start working that way. Megan says, thank you. Can you speak a little bit about any types of comparative analyses we can do? I'm interested in comparing two bodies of text, e.g. comparing two different openings within the same survey. Yeah, the key point, I think, with the comparative analyses is to not think about it as a text analysis problem. That is, you do your two categorizations and then you use the ways you would ordinarily compare different questions. So creating crosstabs, doing correspondence analysis is in general, I think, the easiest way if there are a lot of categories to comparing two alternative categorizations. And Aaron says, I'm talking about the list of items. Yeah, there are various options for delimiters. And so Aaron earlier asked about delimiters. And you remember, I told you there's a whole lot of little options hidden here. Let's go to the spontaneous awareness page. Clicked on too many things. Click on the little output here. And you can see the options here. Now if you can't find something in display, just type and we'll search through, and you can see down here, it's highlighted delimiters. And you can see here, we can control the various options for how we do delimiting. Kylie says, when appending brand tracker data, will the auto categorize function work the same in Q? Yes, it will. Sumaya says, I do have a question, perhaps we're not doing it right, but when we get open-ended responses in a form layout, one line per response, how do we merge it for one view of analysis? And also on the same question by multiple language, when you translate it, has to be analyzed separately. How do we merge all the translated questions to analyze under one? I hope I explained myself well there. Yes, you did. All right. What I would recommend you do in the current version of Q is find the translation option in Q and just search through. It's just a new way of transforming a variable, and it allows you to specify the input language and the output language and deal with multiple languages at the same time. So you just need to have a variable that tells you what language is in what variable, and then translate them all to English, and then run that through the text categorization. In a week or so, the newest version that will come out, it will actually allow you to do that from within the coding or the categorization user interface, just making it a little easier. Please contact me or contact support if you want more information about how to do it. So yeah, Ron says, if an open-ended question is, what do you like about us? Followed by another question such as, what concerns do you have? Is it possible to combine them? It certainly is. What you do is you would create a new variable, and I'll do a stupid little example to illustrate this. I'm going to go I'm just going to go custom code, text. I'm going to type paste, which is a special function for combining things. I'm going to click on my likes data, and I'm also going to click on what other data should I merge this with? Main phone company other. They don't really belong together, do they? But now I've created a new variable or combined variable. And then I would just push this combined, do the coding on that combined variable. And Aaron says, sometimes the comma is present, sometimes it's not. Yeah, look, if the data is really, really messy, it can be hard. But play around with it, because remember I showed you those examples of finding AT&T and ATT and merging together. Even when you've got spaces and stuff, if it's brand lists, if you tell it to look for a specific brand list, it'll be able to deal with the fact that the delimiting is not done properly. Yizian, and I probably pronounced that wrong, I'm so sorry, says, in the semi-automatic coding, where you provide examples for the model to be trained on, how many examples do you have to supply for reasonable accuracy? Great question. You're not going to love my answer here. It depends on the strength of patterns in the data. So you can have a data set with only 200 responses where the patterns are really easy for the computer to find, in which case that 200 responses will do a great job. Or you can have a data set where the patterns are so strange and nuanced and subjective that even 10,000 responses can't build a good model. So it just comes down to how machine understandable the actual text itself is. So as an example, where you ask very specific market research questions, what do you dislike? You tend to find that automatic categorization works really well. When you instead use things like Twitter data, where there could just be any garbage, it's very, very hard for the algorithms to win. Johns says, could be Matthew, not sure, says, when coded open-ended, which are then analyzed as quant, be tested for statistical significance. Yeah, you should do your stat testing, of course. Just any standard stat testing will work fine when you code the data. No issue there that I know of. Anyway, that was a lot of questions. Thank you all for all of our customers out there. Thank you for being our customers. I really appreciate working with you. We will send you a recording of this webinar and the slides as well. Bye now.